All right, we got these two more sections to go through. So this is number of solutions to a system of equations graphically. And then the next one we do is the number of solutions algebraically. So on one we have a graph, on one we don't. And even on the graph one, you don't have to use the graph. I know some people aren't, like they're not super comfortable with graphing. So if that's you, you could do these a different way than graphing if you would like. So for example, I could use substitution here. And I know that 3x, if y is equal to this stuff and y is equal to that stuff, then those two things must be equal to each other. So if I set them equal to each other, let's watch what will happen. So then let's say I subtract 3x from both sides. And it could be like I'm trying to move it to the right or the left. It wouldn't matter. You're doing the same thing. In either case, they're going to cancel. And now I have 2 equals negative 6. Well, when does 2 equal negative 6? It doesn't, ever. So these two lines are going to intersect whenever this is true, but this is never true. So these two lines are not going to intersect, and there will be no solutions. Graphically, what that would look like is, okay, 2 is our y-intercept, so put that there. 3 over 1 is our slope. So from this spot we just put here, I'm going to go up 3 over 1. And there's that line. Same thing down here. So my y-intercept is negative 6. And then my slope is 3 over 1. So from this negative 6 starting spot, I'm going to go up 3 over 1. And you can see, so based on our algebra, 2 is never going to equal negative 6. Based on our graph, they're parallel. These two lines are never going to intersect. So that is no solution. I made a little thing of notes here. So the situation we just had was this, and you could look at this a whole bunch of different ways. In this, yeah, okay. If we get a equals b and they're two different numbers, so this is like what we have here. So a equals b, and this one we just did, we got down to, it was like 2 equals negative 6. That's no solution. That's parallel lines. So that's what we had right here. If you come out with two numbers that are the same, if you get like a equals a, that would be infinite solutions. That would be the same line. So we got these two different scenarios, and this is like the dividing line. These are two examples of infinite solutions, and this is an example of no solution. And that's the game. Do you have infinite solutions, or do you have none? All right, so if I look at this one again, graphically, you're welcome to do it graphically. You don't have to. But if I do this graphically, my y-intercept is 3. So start at 3, and then my slope is 3 over 1. So I'm going to go up 3 over 1 from there, and I get this line here. Well, now my y-intercept is 3 again, so those lines are going to cross at least once because they just did. And then this is down to right 1. So from this spot here, I got to go down to right 1. And you can tell those are going to have exactly one solution. So you can kind of get there quicker. If there's different slopes, so here's another one. No, that does not. Yeah, that's a third category. That's good stuff. All right, so then we're going to go bam, and then if the slopes are different, one solution. So that'd be like two lines that cross. That's what we had here. Let me do one more of these. No, I'm not done. No, go back. I'm going to review it. Stop it. Okay, perfect. This is kind of the other way it could be set up and you'd be asked to graph. So I would do this with the intercepts like we talked about in one of the earlier videos. So I'm going to find the x and y intercept and just plot those 2 points. So the x-intercept here is going to be negative 20 divided by the number in front of the x. So negative 20 divided by 4. So the x-intercept is negative 5. The y-intercept is going to be negative 20. And I'm getting that because it's the one over here. Divided by the number in front of the y. So that's 2. So I just kind of skipped the slope part there. Notice what happened. I just found 2 points. I found the x-intercept and the y-intercept. Connect them and I got a line. Do the same thing down here. So I got negative 30 divided by the number in front of the x. That's your x-intercept, so that's 5. And then negative 30 divided by the number in front of the y. Just so you guys know, if we're at home for, or not, if we're virtual for longer than just this week, I'm going to buy a stylus and be able to write things a little cleaner. Anyway, so my y-intercept here is 2. And there we go. They're crossed exactly once. And if you work this out, they would have different slopes like we talked about. So different slopes means one solution. Wait, what? Oh, this is 5 also. Those are the same line. My bad. So this gives me 5, this gives me 5, so they're both there. This gives me 2, this gives me 2, both there, both there. So that's infinitely many. My bad. All right, I'm gonna explain this one algebraically as well. So one of the things they'll try to get you to do is realize, okay, how do I get from this to this? And they doubled it. So let's say we double that left-hand side. So now we got 2x plus 4y equals 4. So this and this are the exact same equation right now. So I can cross this one off. I don't need it anymore. Well, now look what we have left. If 2x plus 4y equals 4, it can't be true that 2x plus 4y also equals negative 8. 2x plus 4y is what it is. You can't have it equal to two different things. So this is impossible, and it's no solution. If you wanted to look at the intercepts, do 4 divided by 2 for your x-intercept, 4 divided by 4 for your y-intercepts, negative 8 divided by 2 for your x-intercepts, negative 8 divided by 4 for your y-intercept, and there you can see parallel lines, no solution. All right, I'm going to go on to number of solutions algebraically. So now we're kind of looking at this deal here. We want to make, the easiest thing for me to do is see it in this form. X plus by equals c, both of them. So I'm going to set that up. And some of you can see this faster in a different way, and that's cool, do that. But I think for a lot of people it's easiest to put it in that I want to put my x's here, my y's here, and then my equal sign, and then just my number over here. So I'm going to set these two up that way. So this negative 7x, if I want to move it over to the left-hand side, has to become positive. So I've got 7x plus y equals 8. Everything else can stay where it is. This, again, I'm going to move it over. Now it's positive. So I have 7x plus y equals negative 8. So if I rewrite these, it's a heck of a lot easier to see. So now I've got 7x plus y equals this. I've got 7x plus y equals that. It can't equal both of those things. That's not true. No, I want to practice more. All right, same thing. I'm going to set these up in that I got x's here, y's here, equals number. And it's just a lot easier for me to line up that way. So the y is on the left-hand side of the equal sign, so it can just stay where it is. This 4x was to the right of the equal sign. I'm asking it to be on the left of the equal sign, so now it has to be negative. And that negative 8 was already on the right-hand side, so it gets to stay over there. Now this 4x has to move, so it becomes negative. And we get this. So if the left-hand sides are the same, we would look at, okay, is it infinite solutions or no solutions? But the left-hand sides are different. So we're going to get different slopes here. And you could tell that way back here, some of you might have been like, well, wait, if I divide everything by 4, I get y equals 2x minus 4. And Mr. Davis told us if we had different slopes, there's one solution. So you might have done that a while ago. But there's that one. How many solutions do we have here? So again, I'm going to put it in this xy form. You do not necessarily have to do that, but it's just kind of like my fallback. Okay, if I'm stuck, that's where I'm going to go. And some of you are going to figure out your own shortcuts, and that's awesome. So I'm going to move this guy over there. We'll make it positive. And everything else can stay where it was. Move this over there, so that'll become positive 14x plus 7y equals 28. So I'm a little bit tempted right now to say that these two sides are different, but they're not, because watch what will happen if I multiply this entire top equation by 7. This is supposed to be parentheses. If I multiply that entire top equation by 7, well, what's 7 times 2x? It's 14x. What's 7 times y? It's 7y. What's 7 times 4? It's 28. So these are the exact same equation, and that's the infinitely many. All right, one more. I'm trying to keep these under 10 minutes, and I'm a little over, but deal with it. So just kind of another way. Let me just approach this a little differently. How do I get from y to 2y? Well, I noticed that if I want these two to be the same, I'm going to double this bottom one. So let's do that. Let's see what we get. So we get 2y equals 4x plus 12. Well, I can go through and like rearrange things, but what I can see is the y's are the same, the x's are the same, and the numbers are different. So I've got the x's are the same, the y's are the same, and the numbers are different. So you've got, if you worked this through, this part here would tell you that we have the same slope. This part here would tell you that we have different y-intercepts. So you get the same slope, different y-intercepts. They're never going to cross. That is no solution. So I'm going to stop there. Hopefully that helps, but please ask if I can talk you through some more.